Hi guys, so we're back for another day. It's Tuesday the 7th. So we are going to now get into our lesson for today, and we're going to continue with functions. And we're talking about linear functions all week. Yesterday we kind of talked about function rules. Today I want to talk about what is called rate of change, or another way that you guys might know this as is the slope of a function. Or aka how much something is changing. All right, let's get to it. So as you guys know, a rate of change, or the slope, is the vertical change or over the horizontal change, or we like to call it the up and over, or the y over x. In a linear function, the rate of change is always constant. And again, another word for this that we like to use is slope. And then we've also called this the unit rate. So those are all different things that we will refer to a rate of change as. All right, let's keep going. Make sure you get this down. Okay. Find the rate of change in a linear function that models the height of a zip line. All right, so we need to figure out what's happening with our y and then what's happening with our x. Change in y over the change in x. Remember that little triangle means change. So I see here we're starting at 250, and then I'm looking for my next perfect point, which is here at 150, if you guys can see that. So we're going to go down, and then halfway between 250 and 200 would be 25. So we're going down 25. And then we're going over 1, 2, 3, and then we're going over to 100. If you guys can see that, so we're going down 25, and then 150, not 100, and then over to 150. If I wanted to simplify this, these both are divisible by 25. Negative 25, and then it's a negative slope because as we can see it's going down. And think about a zip line, you're going down. You can't go up on a zip line, that's just not scientifically possible. So negative 25 divided by 25 would be 1. Negative 150 divided by 25 would be 6. So your rate of change is negative 1/6. And that kind of means that you are going down a foot every 6 seconds. For every foot you go down, you're 6 feet away. That's what that's going to mean. Sorry. I thought that was a time. All right, let's keep going. There's a rate of change that models the ramp on the road, or the slope of this ramp. So as you can see, we're starting here at 0, 1. And then our next perfect point is negative 4, 0. So our change in y is we're going down 1. And then our change in x is we're going over to negative 4. And remember, so a negative over a negative is actually going to be a positive, and we can see that here because the ramp is going up from left to right. Negative 1 over negative 4 is the same as 1/4. Those negatives cancel out. So the slope here is 1/4. Or you can even say here we go up 1 over 4. All right, let's keep going. All right, what is the change that models the top of the fire truck? So this one's interesting. So if I go up 0, I still go over 1. And so if you guys remember from a long time ago, if a horizontal line has a 0 slope or no slope, this is not slanted at all. So there's no slope here or a slope of 0. And then if you guys also remember, a vertical line is undefined because that would involve dividing by 0, and friends don't let friends divide by 0. So those are just some things to remember. All right, let's keep going. Again, and then also in an equation, in a linear function, we talked about this yesterday, actually. the rate of change is going to be, or your slope is going to be the coefficient of your x. Remember, our x coefficient is the slope, and then our y-intercept is the constant. All right, so make sure you get that down if you need it. What's happening here? Okay, let's keep going. Identify the equation of each linear function. So we have here a line that starts at 3, because every other line is, yep. So we know that our equation, it's going to have a plus 3. And our next perfect point is here. We are going down 1.5. You know what, I'm going to actually do it this way. Okay. We are going down 3 over 1. We're going to skip that perfect point and just go here. It's a little bit easier than dealing with the decimals. So we're going down 3 from 3 to 0, and then over 1 from 0 to 1. Remember, because these are the half marks. So 3 over 1, since it's down, is going to be negative 3x plus 3. And then our rate of change is negative 3. Here, if you can see, our change in y is 2/3. And then our change in x is 2. If you guys see that here. So we're going up 2 over 3. So that is our rate of change. And then our y-intercept is going to be a 0. All right, let's keep going. This one here would actually be a 1/3 x if you did out the slope, because 2/3 divided by 2 would be 1/3. If so my change in y is 2/3 over 2. If I simplified that, 2/3 divided by 2 would be 6 over 2/3 divided by 2 would be the same as 2/3 times 1/2. Will be the same as 2/6, which is 1/3. So that's how we get our slope there. We actually divide that out if you have a fraction. So this will be 1/3 x, and there's no y-intercept because the point is 0, 0. And our rate of change is 1/3. All right. What is the rate of change in this linear function? That's going to be 3/2 or 1.5 if it asks for it as a decimal. All right, so that. All right, an employee is making a candle making company collected data about the burning time. Find the rate of change and between hours 1 and hours 4. What does this mean? So the height of the candle is going to be y, and we're going from 22 down to 13, which is going to be a change of 9, so we're going down 9 over 4. If I simplify 9 over 4, that would be 4 times 2 is 8, and then 1/4 left. So that's 2 1/4. I hope you guys are getting this down. Per hour. Over 1, so that means that in 1 hour the candle is going to burn 2 1/4. That doesn't make sense. Yes, it does. Okay. Again, so from 22 to 13, we're going down 9, and then we are going. This would be a 3. That's why. That's why I knew that didn't make sense. This should be a 3. So from 1 to 4 is a change of 3. Negative 9 over 3 would just be negative 3. That means that the candle is going to burn the height's going down 3 centimeters per hour. Sorry about that, guys. My brain is not working today. Okay. Use values for 1 ounce of candle and a 5 ounce of candle to find the rate of change. So from 1 ounce, so from 5.5 to 27.5 rather, is going to be a change of 22.5. If I add that, no, just 22, sorry. And then from 1 to 5, is going to be a change of 4. So this is a plus 22. This is a plus 4 because it tells us to use the 1 and 5. That's why. And so that is going to mean 22 over 4, if I divide that out, to get the per hour. 22 divided by 4, 4 times 5 is 20, and then you have 2 left over, so this will be 5 and 2/4 or 5.5 ounces that it's going to burn per hour. Again, so it's burning 5.5 ounces per hour, and you can actually see that here in the unit rate, the per hour. So that's another reason why we know that slope and unit rate are one and the same. Alright, so now it is time to go work on your Pearson. Again, I apologize for the confusion with that other one. Just ignore what I was saying for the first part. And alright, I will see you guys on Zoom at 10, and I miss you all. Bye.